All right, so using the coordinates is the first topic that we'll be talking about. So also using distance formula and slope to classify things as quadrilaterals, and distance formula and slope to classify a triangle. If you can't see the board from where you're sitting, tilt to where you can see it, because it won't do you any good with your back towards it. All right, so first things are some terms to review. So take like 2 seconds on your own paper and match the terms that you think go with the correct definition. All right, so formula that can be used to find the length between 2 points. A point that lies equal distance between 2 other points. Ratio of change in y, and so on. So take like 30 seconds and match them up to what you think they are. All right, so what definition, and I'll kind of letter them to make them easier to see. You can do 1, 2, 3, 4, and 5. All right, so for the first definition, a formula that can be used to find the length between 2 points. Which definition closely matches number 1? Yes? Number 4. As in like this one, parallel lines?
No, as like perpendicular lines.
All right, that is correct. So I was asking it a different order, but that is correct. Perpendicular lines does match number 4. So 2 lines that intersect at 90-degree angles, good. So look something like this, right? Perpendicular lines. Now, which of these definitions, A, B, C, D, E, matches a formula that can be used to find the length between 2 points? Yes. B. Any disagreements? All right, good, that's a distance formula. What about number 2? Point that lies equal distance between 2 other points. You can call it out, you don't have to raise your hand.
Midpoint.
Good. Ratio of change in y values to change in x values, or steepness of a line.
Slope.
Good. And lastly, 2 lines that lie within the same plane and never intersect.
Parallel.
Good. All right, if you didn't match it up like this, just kind of go through, make the change. All right, this would be a good quiz question. Just FYI, the quizzes are going to be based on whatever was learned the day before. So if you were absent, just watch the video, go through the notes, and be ready for the quiz. All right, so to review parallel lines and perpendicular lines, we're looking at them right now. A and B are parallel to each other, meaning that they'll never intersect. Here's the formulas for each line. What are you noticing about those formulas?
They both have a fraction in them?
They both have a fraction in them. Are those fractions the same?
Yes.
They are the same. Is it like that for the perpendicular lines? Do they have the same number in front of the x?
No.
No. So parallel lines are unique because they have the same slope. All right, so parallel lines will always have the same slope. Even if the slope was slightly different, if it was like 0.5 and 0.51, they will intersect. But since they're exactly the same, then they're never going to intersect, so that's what makes them parallel. So if I took away these lines, you couldn't see them, but I gave you the equations, you should be able to tell me that those are parallel. All right, so we established that perpendicular lines don't have the same slope, right? So slope in front, it goes in front of the x. Forgot to mention that. right? The M is your slope. So the slopes for these two lines are -2 for the blue line and 1/2 for the red line. Is there any significance to that? Do they look kind of the same? All right, there should be a significance to that. If I were to take that -2 and flip it, make it 1/2, right? Because every time there's a whole number, it's always over 1. If I flip it and then make it negative, so like a double negative would make it a positive, that's why it's a positive 1/2. That's how I get the line that's perpendicular to this one. All right, if that was confusing, I'll just kind of sum it up right here. It's what's called a negative reciprocal. All right, so these are negative reciprocals. So if I asked you, what line is perpendicular to, let's say, this line, so 5/8 x plus 1, all I have to do is flip it. So what would the fraction look like now?
It fits.
Good. And then change the sign on it. So if it was positive here, it becomes negative here. This number can be any number. It could be 2, it can be 4, it doesn't really matter. Because these slopes are negative reciprocals, the lines are going to end up being perpendicular. All right, it'll always have a 90-degree angle if that's the case. Questions about this page? All right, what type of angle do perpendicular lines make?
90 degrees.
90 degrees. All right, if you don't know that, know that. Or at least write it down now so that for the quiz, you know it tomorrow. All right, so same slope, forgot to mention, different y-intercept will be parallel lines. So same slope, different y-intercept. If it's the same slope and same y-intercept, then it's the same line, right? But if it's same slope, different y-intercept, it's a parallel line. If slopes are negative reciprocals, they're perpendicular. All right, anyone need me to stay on this page? All right, so slope. We kind of talked about it a little bit, but just to review, slope is the line that's the ratio of change in y values over the change in x. So it can be shown a ton of different ways. It can be shown like this, change in y over change in x, so the triangle means change. It could be that one equation you learned in algebra 1-2. So y2 minus y1 over x2 minus x1. What else? Is there another way that it can be represented? Maybe like if you have a graph and you're counting, we also call it rise over run. All right, so these all mean slope. Use whichever one works best for that situation. So if I'm looking at a graph and I just need to count the slope, I'll probably just do rise over run. If I'm given two coordinates like these over here, x1, y1, x2, y2, it might be better to use this formula. Again, it's the steepness of a line represented by m in the slope-intercept form equation. All right, so m would be slope. What does the B represent?
That's your
The y-intercept. So good. M is your slope, B is your y-intercept. X and y will normally stay X and y, but if you ever need to plug something in, then it's going to be an X or Y value that's on the line, right? So again, if you're given a graph, you can probably just count the rise over run to find the slope. If you are given 2 coordinates, this one's probably better. All right, questions? Okay. So then next page. All right, the examples, if they're hard to see on your paper, sorry. I can always blow them up on here and you can see them better up here. But first you're gonna find the slope of the line from a graph. So what formula might be best to use for example 1?
y2 minus y1 over 2, or x2 minus x1.
So you're not wrong. You can use that, like you can figure out what coordinate this point is and what coordinate that point is. But since it's a graph, what else could I do? That might be a little easier. Good. So I would probably use rise over run myself for number 1. And then for example 2, since it only gives me 2 coordinates, I'd probably use y2 minus y1 over x2 minus x1. All right, you can use either one for both, but it might be more work that way. So try these out on your own paper. If you have questions, kind of stop me while I'm walking around. But we'll go over these in about a minute. All right, here's our potential answers, guesses. You will learn the correct way to write now. All right, so looking at our graph, I always tell my students to look for points on the line that go through like little crosshairs, right? On the paper, you can kind of see like they already showed you which ones those would be, like which ones go through the center of the grid for each one. But those points might not always be there. You might have to count those points yourself. To use the rise over run method, you just have to pick any 2 points. So I could pick this one, these 2. I could pick this one over here and that one, doesn't matter. But I'll just pick these 2 right here and I just draw a triangle to connect them. That'll help me better see my rise and my run. So how much is it going up to go from this point to that point?
3.
Should be 2. So don't count the first one.
Oh, okay.
And then count 1, 2, right? So it is 2. What is the run? How many spaces to get from here to here? 1. And since it is rise over run, it should be 1 over 2 or 2 over 1?
2 over 1.
2 over 1. Good. Can I simplify that a little more?
Maybe.
What would I simplify it to?
2.
2. Right? I'll still accept this answer, but really this is the final answer. Questions about that? All right, and then again, you could have chosen like a point down here, like maybe you made a larger triangle, but as long as you're simplifying the fraction, you should always end up at 2. So like if I count the rise from like this point to that point, I get 1, 2, 3, 4 for the rise. And what do I get for the run? 2. And then rise over run, 4 over 2. What's 4 divided by 2? 2. So no matter what, I still get an answer of 2. Questions? All right, if you maybe don't like that method, you could always use this next method that I'm going to show you, but it is a little more work, because then you do have to figure out the coordinates for those points. Not that that should be too difficult, but that's what you would have to do. So for example 2, it gives me 2 separate coordinates, right? Because it didn't give me a graph, I could maybe choose to graph it and then count the rise over run, or you can just use this formula. And since you get to use your notes, you don't really have to memorize this formula. You just have to know how to use it. So all you have to do is label one of your coordinates, x1, y1. Does it matter which one? All right, if I label the other one as x1, y1, does it really make a difference? The answer should be no, it doesn't make a difference. So just pick one of the coordinates to be your x1, y1, and the other one to be your x2, y2. You'll get the same answer, assuming that you're doing it correctly. So now that I labeled each number, all I have to do is plug them in. So what number did we say is our y2? 7. What number did we say is our y1? -8. I'll simplify it in the next step, but make sure don't just not include the negative sign. All right, the formula has minus whatever the y1 is, so it's minus -8. On the bottom, what's x2? -3 minus x1, which is good. What happens when I have a double negative? It turns into a positive. So you could just remember double negatives become positives, or I also like to say like add the opposite. Anytime you're subtracting, you add the opposite. So really I have 7 plus 8, which is
15.
good. Down here, anytime you're subtracting, you are adding the opposite. So change the subtraction sign to a plus sign, change whatever sign is on the last number. What's -3 plus -2? -5. All right, if you have a hard time with negatives, use a calculator. All right. 15 divided by -5 is -3. So our slope is -3. Questions about that? If you got it wrong, do you know why you got it wrong? All right, we're now going to switch over to the distance formula. And after we go over just the definitions and example, we'll take like a quick break. All right, so next page, distance. When 2 points are graphed on a coordinate plane, it is important that you can find the distance between them. So here's the formula that will be provided for you, assuming that you bring your notes and you don't lose your notes. Here's the distance formula. Whatever 2 points that you are looking at, so let's say it's a line that looks something like this. You just have to figure out what coordinate A is. Maybe it's 1, 2. Figure out what coordinate B is. Maybe it's -3, -4. And plug them into this formula. So just like we did for slope, make one of them x1, y1, the other one x2, y2, and just fill in the blanks. All right, so if I was doing these two as my examples, so not this example, then I would just plug it into here. So here's the square root symbol. x2 we said is -3 minus x1, so -1 squared plus y2, which is -4 minus y1, which is 2. All right, so that's what it looks like plugged in. You're just labeling them and putting them in the correct spots. I would make it easy on myself, and I would just put this whole thing into Desmos or whatever calculator I'm using. All right, so I'll show you what it looks like on Desmos. Tomorrow I'll show you how to use the actual calculators that you'll be using on your quiz. We have desmos.com. Click on the graphing calculator. You can find the square root symbol. I just type in SQRT, and then it pops up. So you can pull down the menu and put in a square root symbol. And then I type in those coordinates exactly how I had them on my paper. So -3 minus 1 squared. Don't forget the parentheses. -4 minus 2. Squared. All right, and then it gives me whatever number that is. On some of your homework problems, it asks you to it asks for you to give the decimal answer. On other problems, it asks you to give like the radical. All right, so if you're looking at your answers A, B, C, and D, and you're not seeing a decimal, all you have to do is erase the square root symbol. So if I erase the square root symbol, I see what this number should have been before I took the square root of it. All right, so maybe my answer options are square root of 30, square root of 52, square root of 7, square root of 4. If you get a decimal answer and that's not an option, then just figure out what it should have been before you took the square root. Questions? All right, so then on this example, I'll have you guys kind of do this example on your own. So if A is located at -2, 1, so you can draw it out if you want. This might not be an accurate picture, but let's say it's at -2, 1. And B is at -3, 4. Find the distance between A and B using this formula up here. All right, plug that in. When you finish plugging that in, raise your hand. I'll come check your answer, give you the okay, and then you can start the break, or if that makes sense. So that's kind of like your exit ticket to the break.
I stand here.
You can. All right, so what I would do is to make it easier on myself, I would label each one. Like I can pick either one to be x1, y1, and the other to be x2, y2. So if I label it like this and I plug it into the formula that's up here, x2 we said is, well, you did it a little differently. You did it backwards, so I'll do it the way you did it. So you'll still get the same answer. So we'll make this one x1, y1, and this one x2, y3. No, we can go with this. Okay. All right. So this way we're saying that x2 is -2, minus, because that comes from the formula, x1, which is -3. And I know we can simplify that, but I'll just leave it like this for right now. Next, from the formula says plus, parentheses, y2, which we said is 1, minus whatever y1 is, which is 4. Then I would put this in my calculator. And I would type it up exactly how it looks with the parentheses, with the squares, and everything all at once. When I put that into decimals, it gives me 3.16, and it like repeats. But if your answer isn't a decimal, like maybe A, B, and C, D, look something like the square root symbols, you just put it back into the calculator without the square root symbol. Put all of this in the calculator, and then you see that the answer is square root of 10. So take like 5 minutes and then come back. Okay. So application of the midpoint formula. We have the diagonals of a parallelogram bisect each other. The midpoint of segment BD and the midpoint of segment AC are located at the same point. So here's a picture to visualize it. A little bit bigger. All right, and I know this class is like backwards. Geometry 1 is in the afternoon, but you learn that bisecting means that we're cutting it right down the middle. So AC, there's a line drawn between A and C. There's a line drawn from BD. They all intersect at the same point, which is right here in the middle. We're going to use this image down here to find the midpoints of segments BD and AC. So first thing that I would need to do is figure out the coordinates to all of these. Do we remember how to read coordinates? All right, so reading coordinates from a graph should be x comma y. So looking at A, for example, what's the x value for A? That is not the x value. Should see like where the dot is.
You mean like the coordinates?
Yeah, what's the coordinate for point A?
-4, 1.
Good. Remember, here's your x-axis, here's your y-axis. X down here. The one that matches with point A is -4. The y value that matches for point A is 1. All right, what's the coordinate for B?
-2, 4.
-2, 4, good. Coordinate for C, someone else? 4, 4, good. And coordinate for D?
1 and 2.
I would disagree. X should be first. What's the X value at D? 2, 1. All right, any confusion how we figured those out? All right, so now that I have those labeled, I can find the midpoint of each line. So we have a line going from BD, so we need to find the midpoint of BD. We'll do that together, and then I'll have you guys find the midpoint of AC on your own. All right, so for BD, I'm looking at these two coordinates, so I'll highlight them for you. Coordinate B and coordinate D. And the midpoint formula, we said, looks something like this. You have it on the top of your page, but I'll just rewrite it so that you can see it. on the screen. All right, so plugging it into this formula, I should always label my coordinates first. All right, pick one of them to be your x1, y1, the other to be your x2, y2. So what did we say is x1? -2. It's this one right here. You might have it flipped, that's fine. But the way we labeled it, it's -2 plus 2, because that's what x2 is. Always divided by 2, because that's what's in our formula here. Over here we have y1. What's y1? 4 plus y2, which is 1. And then always divided by 2. All right, so scrolling down, just so you can see. And then you can simplify it here in this next step. So -2 plus 2 is 0. And I know we can probably do this in our head, but I'll simplify it in the next step. 0 divided by 2. And then we have 4 plus 1, which is always divided by 2. We can simplify those. What's 0 divided by 2?
0.
And then what's 5 divided by 2? 2.5. All right, so if I was graphing the midpoint, it would be at 0, 2.5 for BB. I can just put a dot there. All right, now you guys are going to take a minute and find the midpoint of AC. All right, whoever said that, say it louder.
It's the same one.
It is the same point, and you know that because it says that in the directions. But what if it said to prove that this was a parallelogram? All right, we're not doing proofs today, but if it said to prove that this is a parallelogram, they should intersect at the same point, right? So you would just show that by finding the midpoint of AC. So even though, yeah, it should be this point, show your work, but I'm going to come around and look at it for the midpoint of AC. All right, practice using the formula so that tomorrow you know how to use it for your quiz. All right, so if your final answer matched this midpoint, then you're on the right track. If you just kind of circle this as your final answer, then just kind of pay attention to how it's set up. Again, it's just a lot of labeling and plugging into the formulas, and luckily you don't have to memorize the formulas for the test. So if you're having trouble plugging stuff in, let me know, and I will give you some tips to help with that. All right, but since coordinates are normally ordered x, y, then in this first fraction here, you should have stuff for x and y, for just the x's, right? And then over here, you would have stuff for just the y's. So according to the formula, the denominator is always 2. Miss Medina. Olivia Dodge? Yeah. Are you Dodge or Riley?
I'm Dodge.
Oh, okay. She is. I guess I put the wrong Olivia as absent. Okay, sorry. Thank you. So, all right. Denominator is always 2 according to the formula. Numerators for the first one should be you adding your x1 and your x2 together. So -4 plus 4. All right, your second fraction should always be you adding your y1 and your y2 together. So 1 plus 4. Simplify it. What's -4 plus 4?
0.
Good. Over here, 1 plus 4 is 5 over 2. Notice we do have the same thing from this point. It might be different in other examples. But 0 divided by 2 again is
0.
and 5 divided by 2 again is 2. Right, so yes, I know it did say it would be exactly the same, but once we get to having to prove things, that's how you can say this is a parallelogram because they do bisect at the same point. Questions? All right, so then now let's talk about triangles. Hopefully this is one of those things that you really remembered. So equilateral triangles, what does that mean?
It means every single side is equal.
Every single side is equal, equilateral, right? So, and this is kind of a rough sketch. Maybe the triangle looks like this, maybe the triangle looks like that. But if I have the same measurement on each side, then I can conclude that it's an equilateral triangle. So that's for that. Isosceles triangles, what's special about those?
It means only 2 of the sides are the same, but one is different.
Good, 2 of the sides have to be the same for isosceles triangles. So maybe it looks like this. So as long as 2 sides are the same, then it's isosceles. And then down here, right triangles, what's special about those?
It's a 90-degree angle.
A 90-degree angle. Right, so really no sides are the same, they're all different. But the big part is that they have 90-degree angles, which is shown by this little square right here. All right, good on that? All right. So on the next page, so on the examples below that one, you're going to have to use distance formula to show that a triangle is this or that a triangle is that. A good quiz question would be, maybe it just gives you a picture of a random triangle like this, and it says, what type of triangle is this? Is it right triangle or is it isosceles? Since there's no like measurements given to you, you might have to use distance formula to figure that out. All right, so if you do distance formula and you find that like these 2 sides are equal, you can say it's isosceles. Make sense? So you would have to know the definitions or the criteria for each to be able to answer that question. All right, so over here, example 1, using distance formula to determine if it's an isosceles triangle, to prove that it's an isosceles triangle. I guess that's the biggest I can make it. So to prove that this is an isosceles triangle, we already established that we need to use the distance formula. So what would be my first step? Can I plug anything into the distance formula the way that it's set up right now?
And then you have to take your points and plug those in.
Good, we need to figure out what the coordinates are if we're gonna be able to plug it into this formula. So here's a formula for reference. Sorry, I'm probably gonna draw a little bit on the picture, but I'll move it. All right, so here's the formula that I'm using for distance formula. And we're gonna start by finding the distance between A and B, right? We're gonna figure out the length of that side. So A and B, distance for that. We need to figure out what's the coordinate for A. So what's the XY value for A?
0 and 2,
0, 2, and then the X and Y value for B?
1, 1.
Did you say 1, 1?
I said 4 and 1.
Should be flipped. Always do the X's first. So it should be 1, 4. Questions about that? So 1, 4 is where point B is. So since those are my points for that one, just plug it into this formula. All right, you can label them. You can have B, or X1, Y1, or flip it if you want. I'll make the other one my X2, Y2. If I label it like this, what's my X2? One minus X1, which is
0.
all right, and then fill in the formula exactly how it looks. Over here, what's my Y2?
4.
And then minus Y1, which is, that's a 2. All right, so 2. So if you don't have this labeled on your picture, you should probably label it. All right, and then it looks like this plugged into the formula. So practice using Desmos, practice entering this into Desmos exactly how it looks. If you need help with the square root symbol. Right, if you entered it into Desmos the correct way, then it should look like this. All right, notice it gives you a decimal. Depending on what your answer options are, it might be fine to leave it as a decimal and just like round it, so you'll approximate it. But if you have your answer options with like the square root symbols, so no decimals, just erase the square root symbol. All right, so just go in between the parentheses and the square root symbol, hit the backspace, and so my answer is the square root of 5. All right, you really would rather use those answers versus the decimals because those are more exact. All right, so the distance between AB is the square root of 5. All right, so that's my AB distance. To be an isosceles triangle, I still need to find what the distance is for BC and the distance for AC, right? Because even though I have two sides the same, maybe BC ends up being the same distance, I still have to confirm that AC is a different distance, right? Because if they're all the same sides, what would that make it? What kind of triangle?
Equilateral.
An equilateral triangle, and you're proving that it's isosceles. So I'll set up BC for you, and then you'll find the distance of AC. So distance for BC All right, we already know what the coordinate is for B. What's the coordinate for C? 2, 2. Sorry, I'm having a hard time seeing. Okay, yes, it's 2, 2. All right, so then plug it into the distance formula. I'll leave B as x2, y2, and I'll change C to x1, y1, and then just plug it in. All right, you can have them switched where this one's x1, y1, that's fine. So if I do it this way, x2 is 2. Oh, it's 1 actually, sorry. 1 minus x1, which is 2 squared, plus 4 minus y1, which is 2. Let's see if I can move this over. All right, so it should look like that if this is how I labeled it. On your calculators, figure out what this would equal and just kind of hold the answer in your brain for a little bit. And I'll ask you all at once. Enter it. All right, so practice using the calculator that I just passed out to you. All right, I don't have a DocuCam, so I can't show you like on the screen, but you'll just practice entering it on that calculator. All right, if the batteries are dead, let me know. All right, so turn it on. Hit the button up here that says second. It's a blue button. And then you'll see like the blue symbols on your calculator. The one that we need right now is the x squared button. So above that is that square root. Right, you find it?
Mine says recommended change batteries.
Okay. Get one from over here. Okay. Do you want to do, Miss Jessica? She was the one who brought you. Can you ask her if there's more AAA batteries? Tell her that one. Okay. If she wants.
Just gonna say how many do you need?
I don't know, they always just give me boxes.
Okay.
Oh, sorry.
No, that's okay.
As much as she can give me, I can
Okay.
return the rest.
All right.
All right, so everyone find the square root button. Speaking out of her over piece. So tomorrow you're taking a quiz and you're not using it. You found it? Okay. You hit second already? Right there. Wait, maybe wrong one. Right here. Second and the one below it. Yeah, you see how the square root symbol is above it? Blue. All right, so square root symbol, the parentheses, I think you can find pretty easy. They're above the 8 and the 9. Right, and then just type in the numbers. So I have 1 minus 2, close parentheses. Do the square root button, which kind of looks like a caret, like under the clear button. Puts a little box for you to enter the next number in. All right, so that button. And then put 2, because we're squaring. So to fit in that little box. Then hit the right arrow out of it. Hit plus, parentheses, 4 minus 2, close parentheses, and square it again. All right, if it doesn't look like what's on the screen, then tell me and I'll help you make it look like that. Question? All right, so type it in exactly how it looks. So distance of BC is a decimal. That is close to 2.24, right? But maybe we want the exact answer. So how can I get the exact answer? What do I have to erase from my problem? The square root symbol. So I'll just type in what's in red on the board. So I'll just leave out the square root symbol. I'll just retype it in with just what I wrote in red. And that'll give me the number that goes under the square root. Does that make sense? And then if you entered it the right way, you get 5. If you did not get 5, let me know and I'll show you what you missed. Questions so far? So this is for BC, right? So if I'm labeling my picture and I'll label it down here. So far we established that AB is square root of 5. Now we know that BC is square root of 5, but we still need to figure out what AC is. All right, because it might be an equilateral triangle, we don't really know. So figure out what AC is using the same steps. We already figured out what the coordinates are, so you just have to plug them into the distance formula. I'll give you 1 minute to do that.
Right triangle.
Let's see. So to show that it's a right triangle, and I'll be honest with you, because I'm not really normally a geometry teacher or an algebra teacher. So I like study for this pretty much days before I teach it to you. Not gonna lie about that. But I don't know how you can use the point to do that.
I was thinking go down.
Yeah, I don't know, because like right triangles, the side lengths could be anything, right? So saying that the midpoint is this, I don't think would show that it's a right triangle. But right triangles, what's unique about them? So the sides could be really any length, all the sides could be different, but what's true for all right triangles? All right, they make a 90-degree angle. So to figure out that there's a 90-degree angle, say like right here, right? It's not shown in the picture, we're trying to figure it out. What you can do is use slope. All right, and that's on page 2 that we talked about that, if you want to look at it real quick. So on page 2, we talked about how perpendicular lines. We talked about how perpendicular lines make a 90-degree angle. So if I can show that these lines are perpendicular to each other on the one that we're working on, then I can say that it's a right triangle. Does that make sense? So what lines like AB, AC, CD do you think might be perpendicular to each other? I would disagree. So, or maybe you're right. Let me look at this one. Do you have something to add?
I wrote the same number, it's once negative, so if one thing will be less than
Good, so we know that for perpendicular lines, their slopes are opposites, right? So, or they're actually called negative reciprocals. So if I can prove that the slopes of each line are negative reciprocals of each other, then we can prove that this is a right triangle, that there is a 90-degree angle here. So yeah, probably the 90-degree angle would go here, potentially. So if I can figure out the slope of AC, so you were right, Shelby. If I can figure out the slope of AC and compare it to the slope of BC or CD, and if I can show that they're negative reciprocals, then I can say that it is a 90-degree angle there, and it is a right triangle. So the coordinate for A is what? 0, 0, 0, 0. Good, and the coordinate for C is? All right, good. I can use that y2 minus y1 formula if I want, or since these do go through like crosshairs, I can use rise over run. I'll just show you with the y2 minus y1 because I think you'll see that more. And you'll be forced to use it if you don't really use that point. So y2, so let's just label it. Y2 would be what? Two minus y1, which is over x2, which is good. Which we get 2 over 2, which simplifies to 1. So the slope of AC is 1. Now let's find the slope of BC. I'm going to erase what I wrote over here because I wrote a lot. All right, so we already figured out AC. And we already know the coordinate for C. What's the coordinate for B? Good. Then we have x1, y1, x2, y2, plugging it into the same formula. So my y2 minus my y1, which is 2, over my x2, which is good. 0 minus 2 is 2.
Negative.
Good. 4 minus 2 is, which simplifies to -1. Is 1, are 1 and -1 reciprocals of each other? Or negative reciprocals of each other? Yes. Because if I take 1, normally it's a fraction, 1/1, and I flip it, it's still 1/1. But then you change the sign on the second one. So yes, these are negative reciprocals of each other. So is this a right triangle? Yes, because right here, where these two meet, is a 90-degree angle. Questions about that? All right, I'm gonna scroll down to the last example. Can you wait like 5 minutes? Because we're gonna take probably a break after this one. All right, so example 3 down here. Using the ideas presented in the previous 2 examples, describe a method that can be used to tell if a triangle is equilateral. So what's one way that I can tell if this is an equilateral triangle? Good, if I figure out that the sides are all the same, using distance formula, good. Then I can prove that. Is there another way? If I prove that all the slopes are the same, that would help me determine if they're parallel lines. Equilateral triangles don't have any parallel lines. Does that make sense? They all intersect each other. So the only one that I could think of is just the distance formula. Questions about that? All right, if all sides are equal, then it's an equilateral triangle. We use the distance formula for that. All right, I can tell some of us are falling asleep, so we're gonna take a quick break. Feedback at 9:25. All right, so you can go to the bathroom now. So now reviewing quadrilaterals. So these are all quadrilaterals here: rhombus, square, rectangle, parallelogram. And what's unique about them is that like squares are also rectangles, right? But can a rectangle be a square? No. So if it says prove that this is a square, for example, I would have to prove that all sides are the same or whatever is unique about each one. So just some criteria that needs to be said about each one that you'll just kind of have to jot down as best you can. A rhombus will have 2 pairs of parallel sides. All right, so rhombuses have 2 pairs of parallel sides. Other things that have 2 pairs of parallel sides. Rectangles. Same thing, 2 pairs of parallel sides. Do parallelograms have 2 pairs of parallel sides? What about squares? All right, so they all really need to have 2 pairs of parallel sides. Squares all right up here. 2 pairs of parallel sides. Rhombus will have congruent sides. So according to this, all sides are congruent, or maybe 2 sets of congruent sides. I'll have to double check on It says all sides are congruent for rhombus. For squares, are all the sides congruent? So write that for square. Congruent sides. Do rectangles have all sides congruent?
No.
No, they do not. So I'm not going to write it for that one. Do parallelograms have all sides are congruent? All right, good. They do not have all sides congruent. Then for squares, so we're kind of done with the set criteria for rhombus. If it meets both of these criteria, it's a rhombus. But for squares, they have another criteria. All squares have degrees that are all 90-degree angles. So they have congruent angles. So in parentheses, all 90 degrees. Would you say that rectangles have congruent angles?
Well, yeah.
All right, I would agree. So like squares, they have all 90-degree angles, right? So they're all congruent. Rectangles also have all degrees, or not all degrees, all angles at 90 degrees, right? Because they're all perpendicular. So congruent angles, all 90 degrees for rectangles. And then for parallelogram, so that's the set criteria for square, it needs to meet all these three. Here's the set criteria for rectangles, it needs to meet those two. For parallelograms, it's just this one. So you see how all of these are parallelograms, but not everything is, say, like a square, right? The more specific it is, like squares, can't say that these are all squares, only squares. Questions about that? All right, so I'll give you like 10 more seconds if you're still writing to have that down. Otherwise, you'll have to look at it from the online notes. But on the next part, we're going to have to like prove that a rectangle that's drawn is in fact a rectangle. And we're going to use the formulas we've already learned to figure that out. Oh, and then just kind of sketch it. Parallelograms are like a sideways rectangle, right? That's not an exact drawing, but. Right, and then rhombuses are kind of weird. They're like, they could look like this. They could look like a bunch of different things. All right, so going to the next example. All right, so prove that this graph is of a rectangle using slope and distance formulas. So kind of tedious problems, but you should know how to use it using the slope and distance formulas. Because rectangles, if you look at the criteria we just talked about, have two sets of criteria, we need to prove that the two sides are parallel and that they make congruent angles. So I can prove that these are parallel to each other, like these first two sides, by figuring out the slope. What's the slope of line AB? Does it have a rise? Does it go up or down? All right, it does have a rise. It goes up on the -8. Does it have a run? Does it go to the left or right at all? Line AB.
It goes from -8 to positive.
So what you're talking about, look at the screen showing, would be a line that goes from like here to here. But we're just talking about this line.
Oh,
So does this line have a run at all? So it would be 0. Can something be divided by 0?
no.
All right, if you try it out in your calculator, -8 divided by 0, it says error, right? That means it's undefined. So my slope for AG is undefined. In order for this to be parallel to that line, this also needs to be undefined. All right, so for BC, what's the rise on this one? It goes up at the 10 mark, right? So my rise is 10. Does it have a run? Does this line here go left or right? Right, look at the board. Does this line right here go left or right at all? No, so its run is 0. So 10 divided by 0 again is undefined. So are these two lines parallel to each other?
Yes.
Yes. So that's one way to show that it's parallel. If I can prove that these lines over here that I'm drawing in red are parallel to each other, that's another good indication that this is a rectangle. So for AB, line AB, do I have a rise at all?
No.
I do not have a rise at all, right? It doesn't go up or down at all. It doesn't go like that. All right, so no rise. It does have a run. I could put the y value for the run, but it doesn't really matter because 0 divided by any number is what? 0. So the line AB has a slope of 0. All right, if I can prove that the line that's like directly across from it is parallel to it, then I could say that it's a rectangle. Does that make sense? So we're trying to see if this line down here from CB has the same slope. All right, does it have the same slope? The rise, I could put the y value for that. It's -3. All right, no, sorry. Does this have a rise? CD. Does it go up or down? Try again. This line right here. Does it go up or down at all? So rise is 0. The run, I could put the y value there, but again, it doesn't really matter because 0 divided by anything is 0. So since these have the same slope, are these lines parallel to each other? Yes. All right, so that's how you use slope to prove that it's a rectangle, but we're not quite done yet. All right, because we figured out that these are parallel, that's two sets of parallel lines. That's not specific only to rectangles, right? It could be a parallelogram, it could be a square, it could be a rhombus. So we also need to prove that all the angles are 90 degrees. All right, we have to prove both. So what can I use, like what formula, what theorem, whatever you want to call it, can I use to prove that like this is perpendicular to each other? So like, how do I know that there's a 90-degree angle here? Exactly, you can use the slopes, which we already found. So like the slope of AD we said is undefined. The slope of DC or CD we said is 0. And I know it's like weird, the undefined part, whatever. But would you say that those are reciprocals of each other?
Yeah.
Yes, the opposite of having 0 on the top versus 0 on the bottom, that would make these negative reciprocals of each other. All right, is that the same for CD and BC? So now we're looking at these two. Is undefined the opposite of 0?
Yeah.
Yes. So we have a 90-degree angle there. For AB, so looking at these two now, so having a slope of 0 versus a slope of undefined, are those opposites of each other? And then lastly, slope of AD, we said is undefined, but we use a different color for that. Said undefined for AD. For AB, we said that it's 0. Are those opposites of each other? Yes. So did we finish proving that this is a rectangle? All right, good. Any questions? All right, you can also use a distance formula, but I did not, because I felt like that would take long. All right, ready to move on to the next one? All right, so I think I'm gonna skip the one about rhombus and squares, just because that one is kind of like the one we just did. So we're gonna look at bottom of page 7. So problem 1, classify the following triangle as either equilateral or right triangle. Just looking at it, and I know this isn't a drawing that's like to scale, but just looking at it, what do you think it will most likely be? All right, and why would it not be an equilateral possibly? Good, you can tell just visually that all these sides are different lengths. It could, it didn't give us that option, but we could also verify if it's an isosceles or not. All right, so we just need to prove now that it's a right triangle. So does this angle right here look like it would be 90 degrees? No. What about this one down here? No. So it's probably this one that looks more square, right? What do you call it when the angles are less than 90 degrees? Acute. So looking at this, acute angle here, acute angle here, we're trying to figure out if B is 90 degrees or not. Because it looks like it is, but we need to know for sure. All right, what can I use to figure out that it makes a 90-degree angle? Good, if the lines are perpendicular, so if line ED is perpendicular to line BF, all right, this symbol here means perpendicular, then I can establish that it does make a 90-degree angle. Then there is a 90-degree angle. All right, so if I can figure out the slope for each one, that's one way to figure it out. What is the coordinate for E? What's the, good, it is 1, 4. So the X value for E and the Y value for E. What is the coordinate for D?
2,
Good, 2 and 1, good. So if I find the slope for ED, so ED slope, here's that formula again. I would write this down as I'm doing the example so that you can match it up on your quiz. Here's the formula for slope. If I plug these in, x1, y1, x2, y2, then I can figure out the slope. All right, try it on your own paper. I'll do it on the screen. All right, if you got the slope of -3 for ED, then you're on the right track. If you didn't, just kind of look up at the board and see where you went wrong. What other line do I need to find the slope for? Yeah, good, because that's the one that's like also on the potential 90 degree. Right, so find the slope of DF. I'm doing it on the board, but you should be trying it on your own paper. I'm just checking your answer. All right, and then if you got your slope for DF as 1/3, then you did it correctly. Even if you switched up which one is excellent. Which one is not. All right, now looking at the slopes that I have here, is 1/3 the negative reciprocal of -3? Or vice versa, is -3 the negative reciprocal of 1/3? Yes, they are negative reciprocals. I forget how to spell reciprocals, so sorry if I'm spelling it wrong. All right, they're negative reciprocals. So does it in fact make a 90 degree angle there? Yes. All right, good. So that's how you prove that. All right, so that's how you know for sure that it's the right time. Questions? All right, I want to give you time for the practice. So if you want to see the solution to problem 2, I do have it posted in Google Classroom, but I'm going to pass out the practice now. So just know, like, if you want to see how these other problems that we skipped are done, I do have my work shown in the notes in Google Classroom. Let's see, where is it? All right, I just uploaded them. I'll normally upload them after class so that no one's just staring at it instead of learning it in moment. But it's in here, right? You can scroll through and see what those answers are. The practice looks like this. Hold on, I'll go back to this. So here you'll scroll through to see the work done for all of them. You can take better notes at home. But the practice, I'm giving you a worksheet, but you're uploading your answers using a Google form. So you're gonna get a paper from me that looks like this. And at the top, you'll see like when you finish this assignment, ensure that you're submitting your answers on Google form. I won't be really collecting papers from you except for the quiz. All right, so once you put your answer in the Google form, you'll see if you got it right or not. So then you can see in real time, like if you're getting the hang of it, or if you need to ask for more help. All right, anyone not get one from me? All right, so work it out on your paper, come up with your answers, and then when you have finished it, you'll go to Google Classroom, click on the practice, click on this link right here for the Google form. And then it says like question 1 with option B. All right, that's how I'm giving you the grade for these items. All right, you only get 1 attempt, and I am looking at your scores, like if you get a 0 on it, I might deduct some points, but like just check it, make sure that you use that 1 attempt wisely. Any questions? All right, so class ends at 10:15. No, you do not have to leave early if you finish early. So just use the time wisely, make sure you're ready for the quiz